Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 2.5a of our virtual algebra 1 text, focusing on how to solve mixture problems. Before we get started with the examples, let's go ahead and take a look at the formula that will be guiding our problem solving process. So the formula that we're going to be using is as follows. C1V1 plus C2V2 equals C3V3. Okay, this just basically means concentration of substance 1 times the volume of substance 1 plus concentration of substance 2 times volume of substance 2 equals concentration of substance 3, basically the combination of the two, 1 and 2, times the volume of substance 3. Okay, so C1V1 for the first substance that we're mixing, and then C2V2 for the second substance, and then C3V3 for the mixture. Alright, and then you also want to remember that V3, the volume of the mixture, is basically the sum of the volumes of the individual components that were mixed together to yield the mixture. So V3 is V1 plus V2. Alright, let's take a look at question 1. It reads, a metal alloy weighing 2 milligrams and containing 80% nickel is melted and mixed with 3 milligrams of pure nickel. What percent of the resulting alloy is nickel? Okay, so we're mixing two substances, a metal alloy and nickel, pure nickel, to generate another alloy. Alright, so let's go ahead and identify what we know and what we need. So the metal alloy, that's going to be 1. Okay, and then let's write down the formula first before we get started with the problem solving process. So hopefully you remember what the formula is. If you don't, well, here it is. The formula is C1V1 plus C2V2 equals C3V3. Okay, so the metal alloy is our first substance. So the concentration C1 is the concentration of nickel in this substance, in this metal alloy. So how much nickel is there? The concentration is 80%. So C1 is going to be 80%, but we have to convert this to decimal form, which basically means we move the decimal point to the left 2 places, 1, 2. Alright, so 80% is 0.8. V1 is the volume of the first substance, which is the metal alloy. How much metal alloy do we have? 2 milligrams. It says weighs 2 milligrams, so 2 milligrams. Okay, so that's that for 1. For 2, what's the second? What else? What are we mixing with this metal alloy? We're mixing pure nickel. Okay, so pure nickel will be our 2. So what is C2? The concentration of nickel in pure nickel. There is only nickel in pure nickel, so the concentration is 100%. In decimal form, you move the decimal point to the left 2 places. So 100% is going to be 1 in decimal form. Now, what is the volume of pure nickel? V2, volume of pure nickel, is 3 milligrams. And then alloy, the resulting alloy, we're going to call that 3. This is the mixture right here. Okay, so C3 is going to be the concentration of alloy in the mixture. What percent of alloy is there in the mixture? Well, if you look at it, we're asked to find that. So that's the unknown. We're going to call it X. V3 is the volume of the mixture. We talked about this earlier. V3 is going to be V1 plus V2. which is simply 2 plus 3, which equals 5. So that's it. Alright, so we have one equation, one unknown. Let's go ahead and substitute everything into the formula C1V1 plus C2V2 equals C3V3. C1 is 0.8 times V1 is 2 plus C2 is 1 times V2, which is 3. C3 is x times V3, which is 5. Alright, let's simplify that. 0.8 times 2, you can do that in your calculator. You get 1.6 plus 1 times 3 is 3 equals 5x. Now on the left side of this algebraic equation, we have two constants that we can combine. So we can combine 1.6 and 3. 1.6 plus 3 is 4.6. So 4.6 is equal to 5x. And then to get our concentration of the alloy, the resulting alloy, we need to get rid of this 5. 5 is connected with this x by multiplication operation. So to undo multiplication, you divide, okay? So we're going to divide both sides by 5. And that is going to give us x equals, let's divide that with our calculators. 4.6 divided by 5 is not 0.92. So 0.92, that's the decimal form of the concentration of the resulting alloy. So if we change this to percent, we're going to reverse the procedure that we carried out earlier. Remember earlier we moved the decimal point 2 places to the left to go from percent to decimal. If you're going from decimal to percent, you do the reverse process, which is to move your decimal point 2 places to the right, 1, 2, or just simply multiply by 100. This is equivalent to multiplying by 100. So our answer is going to be 92%. Okay? So let's write out a statement to state the meaning of this answer. The concentration of nickel in the resulting alloy is 92%. Okay, so that's that. All right, let's take a look at number 2. It says 7 gallons of 80% acid solution was mixed with 3 gallons of pure water. Find the concentration of the new mixture. Okay, all right, so let's start off by writing down the formula again. So the formula for calculating mixture problem, C1V1 plus C2V2 is equal to C3V3. Okay, where V3 is V1 plus V2. Let's do it. So, solution. Alright, what are we mixing here? We're mixing acid solution. So acid solution will be the first substance. We call that 1. Acid solution is 1. Okay, so what is C1? C1 is the concentration of acid in this solution. So the concentration of acid in this acid solution is 80%. So we convert that into decimal by moving the decimal point 2 places to where? To the left, 1, 2. Okay. And that's going to be 80% is equivalent to 0.8. Now, what's the volume of the acid solution? V1. The volume of the acid solution is 7 gallons. Now, the next mixture we're combining is what? Water, pure water. So pure water is 2. Okay, so C2 is the concentration of acid in pure water. How much acid is there in pure water? There is none, so 0%. In decimal form, 0% is just 0. Now, what's the volume of pure water that we have? V2 volume of pure water is 3 gallons. All right, so that's going to yield a new mixture for us. And the new mixture is 3. Okay, so what's the concentration of acid in this new mixture? The concentration of acid in this new mixture is what we were asked to find. So let's call it X. Okay, we don't know. And then the volume of the new mixture is simply V1 plus V2, the sum of the volume of the components that are added. So it's going to be 7 plus 3, which is 10. Okay? So now let's put in the components into the equation. C1 plus V1 plus C2 V2 equals C3 V3. C1 V1 is going to be 0.8 times the volume, which is 7, plus C2 is 0 times the volume, which is 3, equals C3 x times the volume, which is 10. Okay. Now I can multiply this out with your calculators. 0.8 times 7 is 5.6. So 5.6 is equal to, let me show you the steps here. I don't want to skip steps so I don't lose anyone. So it's 5.6 plus 0 equals 10x. So since these two are constants, we can combine them. 5.6 plus 0 is just 5.6 equals 10x. And then we're going to proceed to divide both sides by 10 because we want to undo this multiplication relationship between 10 and x. So divide both sides by 10, and then you're going to end up with 5.6 divided by 10. You can use your calculator, or you can just try to convert 10 to 1, so that can be accomplished by moving the decimal point one place to the left. Okay, so you move your decimal point one place to the left on the bottom. Do the same on the top. All right, so you end up with 0.56 equals x. Okay, so if x is 0.56, what is the percent equivalent of 0.56? You can simply move your decimal point 2 places to the right or multiply by 100. It will achieve the same result. Okay, so let's do the fast way. Move your decimal point 2 places to the right. That will convert a decimal into percent. That tells us that x is equal to 56%. Now, what does this answer mean? This answer means that the concentration of what? The concentration of acid in the new mixture is what? And the new mixture is 56%. Okay? All right, let's take a look at question 3. So we have 9 cubic yards of soil containing 55% silt was mixed with 6 cubic yards of soil containing 35% silt. What is the silt content of the mixture? All right, so let's go ahead and take a look at this problem. So let's start out by writing down what the formula is for mixture problems. So the formula, do you remember what the formula is? C1V1 plus C2V2 equals C3V3, where V3 is V1 plus V2. Okay? All right, so we have two things we're mixing here. So we have the 9 cubic yard soil and the 6 cubic yard soil. Let's just use that to name it. So we're going to call it the 9 cubic yard soil. That's the first one. Okay. So with this one, let's find the concentration. C1 is 55% silt, which if we convert to decimal form, you move your decimal point 2 places to the left. So that's 0.55. And then V1 is the volume of soil, the 9 cubic yard soil, which is just 9 cubic yards. Alright, and then we're adding that with the 6 cubic yard soil, which is 2. Okay, so the concentration of the 6 cubic yard soil is 35% silt. If you convert that to percent, you move your decimal point to the right, to the left 2 places, 0.35. And then the volume, um, the volume of the second soil, the 6 cubic yard soil, V2 is 6 cubic yards. And then this is mixed together to yield a mixture. So let's call this mixture 3. Alright, so the concentration of this mixture, the silt concentration is unknown, so call it X. The volume of the mixture is simply V1 plus V2. So we're going to add it up. Okay, we're going to add 9 plus 6, which is 15 cubic yards. Now what we're going to do is we're going to put in all the information we have into the formula. C1V1 plus C2V2 equals C3V3. Okay, so if we put them all in, what are we going to have? We're going to have, let's see, C1 is 0.55 times V1, which is 9, plus C2, which is 0.35 times V2, which is 6, equals C3, which you do not know, X times V3, which is 15. Okay, so we can use our calculators to carry out these multiplications here. So 9 times 0.55 is 4.95. So we have 4.95 plus 0.35 times 6 is 2.1 plus 2.1 is equal to 15x. Now these two are constants, 4.95 and 2.1. They are both constants that we can combine. So 2.1 plus 4.95 yields 7.05. So 7.05 equals 15x. And then to get x by itself, what we're going to do is undo this multiplication relationship between 15 and x by dividing both sides by 15. Alrighty, so we're going to use our calculators to carry out this division. So let's do it. 7.05 divided by 15 is 0.47. So what does that tell us? It tells us that x is equal to 0.47 in decimal form. So the concentration in percent, you just multiply by 100 or move the decimal point to the right 2 places. Okay, which will yield 47%. So what does this answer mean? This answer means that the concentration of silt in the mixture is what? The concentration of silt in a mixture is 47%. Alright, so how well did you master the contents of this presentation that we just covered? To demonstrate mastery, we would like you to try out the following problems. So what you're going to do is go ahead and pause the video and work on these problems. And then when you're done, click on play and we are going to display what the answers are for you. Alright, hopefully you had a chance to try out these problems. Now let's take a look at what the answers are. The answer to question number 1 is 42%. The answer to question number 2 is 84%. The answer to question 3 is 43%. And the answer to question 4 is 21%. Thanks so much for taking the time to watch this presentation. If the contents of this tutorial was helpful in your studies of mixture problems, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the problems we displayed, the ones we solved or the ones we asked you to solve, do post it in the comment section below and we'll be glad to assist you. Don't forget to subscribe to our channel for updates to other tutorials in our Algebra 1 on virtual text. More videos, worksheets, games, tools, and support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.